right, this is the day 5 homework answer key. Again, hopefully you went through and checked your answer key here first and checked all of your solutions to the systems. I'll kind of talk through the graphs. The graphs is really good review for our quiz that we're going to have tomorrow. Then the solving systems part is not actually on the quiz, but that will be some additional work that you're going to be doing afterwards again to practice those. So taking a look at the first one, looking at the graph, the r equals 2, I'm going to start with the second one just because that's easier. R equals 2 we know is just a circle with a radius 2 centered around the pole. Again, think about all that distance. Every distance from the pole is at 2. That's what forms the circle with that pole at the center. Then we know that this graph right here is going to be in the shape of one of our roses. It has 3 petals. Remember, when there's an odd number in front of that theta, that means it's going to have that many petals. So a couple ways, I actually showed 2 different ways here to graph this one here. So looking here, we can see if I know that this is going to be a rose, I know my petals are going to be all 4 away from the pole. Again, sine of 3 theta, really, again, the sine graph is going to only have a range from -1 to +1. So that's the biggest and then the smallest values. So the furthest and away from the pole it could be is 4 units away. So I said positive or -4. Essentially, you could actually just go through and find the positives on this one. Since we know there's only going to be 3 poles, we know it's just going to go back and repeat through the negatives afterwards. So again, that's another option for you. But what if I just did this one here? Again, where the sine is equal to 1, I did over here the sine is -1, so 3 theta. Again, we have to go all the way from 0 to 6 pi. So I have pi over 2, 5 pi over 2, and 9 pi over 2. When we divide by 3, we get our values here. And again, you'll notice that's actually the ones that have the positive 4. So at pi over 6, 5 pi over 6, and 3 pi over 2. That's where our 3 petals are in that positive direction. If you look at the negative ones, again, it's actually just a repeat. At pi over 2, it's going to be negative, so that would put it down here, kind of where that 3 pi over 2 one was positive. At 7 pi over 6, again, it's negative, going where the pi over 6 also is. At the positive, 7 pi over 6, it'd be the negative. And then 11 pi over 6, it's negative again as well. So you technically wouldn't really need to find the negative on that. We also talked about another way to do this. Again, I like to show them both. I will take either of these. It's whichever way you think of solving first. A lot of them, we started with r is equal to 0. So if you wanted to do this way, we could find where r is equal to 0. That just tells us, again, where it's at the pole, where it intersects the pole. So if you put in 0, that means the sine of 3 theta has to be 0. So 3 theta is going to be every place where the sine is 0. So all the way up to 6 pi. So 0 pi, 2 pi, 3 pi, 4 pi, and 5 pi. If we divide by 3, we get all 6 of these. But this is not where your petals are. That's just where it goes through the pole. But remember, if it crosses through the pole at 0 and at pi over 3, that means the petal has to be halfway between. That's the way that one of the ways we had thought about finding that where that petal is. So at 0, pi over 3, again, halfway between is pi over 6. So if I put in pi over 6, again, we're going to do 4 times the sine of 3 times pi over 6. So that's really the sine of pi over 2, which is 1. 4 times 1 is 4. That's a positive 1. If I go halfway between pi over 3 and 2 pi over 3, here's pi over 3, here's 2 pi over 3, halfway between would be pi over 2. Now be careful on this. If you put in pi over 2 in here, 3 pi over 2 is sine of 3 pi over 2, sorry, is -1, times 4 would be -4. That's why that one's down here at the negative. If you plug in halfway between here, 2 pi over 3 and pi, that's going to be 5 pi over 6. And if you plug that in, we get +4, so we get our third one here. Again, we don't need to actually go through and find the rest of them. It's just going to be a repeat. So that's a good review on the graphing part of it. Now for the new part with the systems. So, okay, we can see that one of the things I like to kind of point out right away is we can see that we should get 1, 2, 3, 4, 5, 6 solutions. Notice none of our solutions are at the pole, so we don't have to worry about that, but we need to find those 6 solutions. Well, when we do it algebraically, we end up finding all 6 of those solutions. So we put 2 is equal to 4 sine of 3 theta. We want to find out where the sine of 3 theta is 1/2. So sine is 1/2 at pi over 6 and 5 pi over 6, but we have to go all the way to 6 pi because of that 3 theta. When we divide by 3, we end up getting all 6 answers. And again, you can kind of think, okay, if this is 1/6 pi, 1/18 pi would be, extra skinny, like a third of that one right here. That would be about right here, and you could kind of count your way around and kind of tell that that's where they would intersect. All right, let's look at number 2. Looking at the graphs of this here. Again, I'm going to start with the one that's easier. We know this is a circle. We gave you the decimal value. Again, it doesn't have to be perfect. It's just to get an idea. Even when r is negative, that's okay. That's just, again, going to be a circle going all the way around. So if I substitute that in, again, if this is r, I can put that into my equation. Square it, we get 18. Divide, we want to know where is the sign 1/2. So that means 2 theta is pi over 6 and 5 pi over 6. But again, because it's 2 theta, we have to go all the way to 4 pi. So add 2 pi to both of those and get our other 2. And then again, divide everything by 2. Taking a look at the graph, again, we can see we have 1, 2, and 3, 4 solutions here, and we get our answers. Okay. Looking at number 3. This one, you'll notice that I scaled the axes here a little bit. So this right here, it's scaled. That is where r is 3 on the outside, just to make it a little bit easier to see here. So, looking at the graphs of them here. Again, I didn't show all my work. For your quiz tomorrow, you're going to need to show your work, but I'll talk through our work here. So if you put in 0, so the first one here, sine of 0 is 0, and then 1 plus 0 would give us 1. Our first point is right here, if you can see it. And then sine of pi over 2 is 1. 1 plus 1 is 2, so that's this point up here. Sine of pi is 0, so we come back down to 1. And then the sine of 3 pi over 2 is negative 1. 1 plus negative 1 is 0. We come in here. This creates our cardioid along the way. So the pink one is our first graph. Second one is really similar. It's in purple here, but here if I start at 0, we get 1. But if I put in pi over 2, notice this time I get 0. If I put in pi, we get 1 minus 1 minus 0 gives us 1. Sorry. Then if I'm at 3 pi over 2, that's 1 minus negative 1. That's why we're down at 2. And it comes back around. Again, this is our cardioid. If you set it equal to 0, like if you did the whole r equals 0, you would find that it would have one place that it would cross through the pole. That's your kind of hint that this one's going to be our cardioid. Okay, set them equal to each other. We solve it. And notice we get 2 solutions. However, when we look at this, we can tell, that's why we need the graph here. We can tell that there are not just 2 solutions. There needs to be 3 solutions here. So we really need to go along and think about, okay, 0 and pi, notice, are definitely solutions that we have for both of them. You only need to pick one of these here. Okay, you only need to pick one. It doesn't matter. Let's say we started with that r equals 1 sine of theta. Let's say we did that one. I had a couple questions on this yesterday going along through it. So again, you can do it kind of visually or think about it algebraically, a couple different ways to do it. So if I'm along the first one, that was my pink cardioid here. We basically want to know where is that cardioid equal to 0, because that's where it crosses through the pole here. So again, we started here at 1. This was pi over 2. At 0 it was 1, and pi over 2 here, there's theta is pi, and here is theta is 3 pi over 2. So right here in the center was at 3 pi over 2. That's why I have that one along this one. But if I follow along the purple one, Again, we've got our point here at when theta is 0, but right here where it crosses through the pole, that's at pi over 2. Again, if you're not sure, you can set up, okay, you want to know basically where r is 0. So if you graphed it and went through some of the work, you might have, oh, sorry, a little sloppy, have already done that. So where is the sign here? We want to know -1, and that is at pi here. Sorry, 3 pi over 2, if I can, struggling with this again. Okay, you get the idea, at 3 pi over 2, and again, that's how we get that answer right there. We can go through and set r equal to 0. All right, again, you only need to pick one of those that shows that it goes along that specific cardioid there. Last one here. Looking at the graphs of them, r equals cosine of theta is the easier of the two graphs. We know that one is just a circle that has the diameter here of, we've got 1 on there. So looking at this one here, let me go. You know what? I didn't write on here that I scaled this one. Scaled. This would be r is 3 right here, just to kind of look at it there. So this is where r is 1. So looking at our graph here for the second, oh, if I go through the first one again, so if theta is 0, cosine of 0 is 1. That's why it's out here at 1. Going pi over 2, cosine of pi over 2 is 0. Cosine of pi is -1. Again, that puts it back over here. And if I kept going around again, it would just repeat it. We can also do the pi over 3's because cosine of pi over 3 is 1/2. Again, this is scaled, so all the way on the outside here is r is 3. I forgot to write that part down on there to help you out with it. All right, 1 plus the sine of theta. If I go through this, if sine of 0 is 0, so we're out here at 1. Sine of pi over 2 is 1. 1 plus 1 is 2. Sine of pi is 0. 1 plus 0 is 1. And then sine of 3 pi over 2 is -1. 1 plus -1 is 0. So again, that's going all the way around. I also did the pi over 6's because the sine of pi over 6 is 1/2. 1 plus 1/2 would be 1/2. So this is actually where it's at 1/2 to get those points there for our cardioid. All right, so we can tell from our graph here that there are only 2 intersection points here. We've got 1 here and 1 here. So if we went through and solved this, set them equal to each other since they both equal r, this is going to be one when you have a cosine and a sine, you want to try and get them squared so that way maybe you can use one of our Pythagorean identities. So I got them both on the same side and squared both sides. Cosine squared plus sine squared is 1. Subtract the 1. If we divide by -2, that tells us that the cosine has to be 0 or the sine has to be 0. So cosine is 0 at pi over 2 and 3 pi over 2. Sine is 0 at 0 and pi. However, this looks like there are 4 intersection points. That's why you need to look back at the graph. There's only 2 intersection points, so we need to go back and think about where do they actually intersect each other here. So looking at our graph, you can look at the graph or you can think about plugging them back in and seeing which ones actually work. Remember, you might have some extraneous solutions when you square them here. So if we are at 0, both of them were equal to 1 at 0. That was really kind of like the starting point. So that is definitely one of ours here. At pi over 2, up here at pi over 2 on our cardioid, that is not equal to 0. That is not a point of intersection. So pi over 2, not one of our solutions. Following along here at pi on our cardioid, it was equal to 1. That's not going through. That's not the same one right here. So that one is not a solution either. But coming around to 3 pi over 2, they are both equal to 0. So that is our other intersection point. All right, we're going to have a couple more of these to practice later this week. Tomorrow you have a quiz, so practice the graphs especially for those. The solving the systems won't be on the quiz tomorrow, but the graphing stuff all will. All right, let me know if there's questions. Bye, guys.